So last time we defined and studied real projective space, right? And it was just the space of lines in Rn plus 1 through the origin. So we have this we identify this point with this one, where lambda is not a but it's a non-zero number. Well, we just repeat the same construction, but this time we use complex numbers instead of real numbers, and we get so-called complex projective space. So Cn plus 1 minus 0. I threw, of course, 0 means the point 0, 0, 0, 0, okay? And then we just, this time we use usually, Z, and we identify this point with any non-zero complex multiple, and lambda is this time non-zero complex number. Yes. Aha. Yani mesela evet. Orada tam beceremedik. Dediğim gibi o kolay bir problem değil. CPN'de ise o zaten mümkün değil. Yani affine space'in içine hiçbir zaman girmez. Da kendisi zaten hani işte olabilecek en halinde. Ya orada o embedding fonksiyonu zaten bir parametrization. Evet. Yani o, ama onun için yapmadım onu. O hani işte işin bir tarafında da cebir var. Hani onu da görmenizi istedim. Oradaki construction'lar, benim yaptığım şeyler ona özgü de değil. Çok daha genel bir teorinin özel bir hali o. Yani örneği. E, Orada aslında embedding teorem var, işte group action var vesaire var. Onun kendisi zaten bir derya deniz konu. O sadece bir örnek orada. Okay. In particular, CP1 is just okay. Again, is in the case of real projective space, I can write this as the union of U0, U1 up to UN, where UI is the set of equivalence classes. We, as usual, denote the equivalence class like this, so that the ith coordinate is not 0. And this is a copy of Cn, as usual, where you identify this equivalence class with the n tuple. Which n tuple? You just divide z0 by zi, the non-zero coordinate, and you come to zi over zi and zn over zi. But you just ignore this component because it's always 1, so you just ignore it. So this means what? We may cover CPN by n plus 1 copies of Cn, okay? Each of these UIs is a copy of Cn, and we have n plus 1 of them, and they cover this projective space. In particular, CP1 is just a copy of U0 and U1, and as in the case of RP1, we have a similar construction. You see, this is just a pair of, let me just, okay, write like this, Z0, Z1, where Z0 is not 0. And we identify this with C because N is 1. And what is the identification? We just identify this point with, let's say, Z0, sorry, Z1 over Z1, Z0. And similarly, we have U1. This time, Z1 is not 0. And this also can be identified with complex numbers. And this time, identification is just Z0, Z1 is identified with Z0 over Z1. So, these are the same points. These are the same points. If I call this point, let's say, omega, then what is this? This is just 1 over omega. Okay? Ya da şey diyeyim, Z diyelim. Hani Z dediğim şey yok. Ya da kafa karıştırmayayım ya. Tamam, şöyle omega diyeyim. Bu nedir? 1 over omega. O halde ne elde ettik? CP1 is a two copy of complex line. This is a complex line, okay? It's the two-dimensional. Actually, it is just the plane, R2, real two plane, but it's complex line. So instead of U0, I can write C. And then instead of U1, I can write C. And what we do, this W is a point here, and 1 over W, the same point lies here. So we can just write it like this. I have a point here, W, let's say, and identify with 1 over W, as in the case of real projective plane, okay? This is disjoint union. So we may picture this as follows. Each complex plane, complex line, I am sorry, is actually R2. So, okay. And you identify all the points except the origins. And whenever I take a point here, let's say W, I identify it with the complex number 1 over W. What is 1 over W? That is just W bar divided by norm squared W. So complex conjugate means it is just rotated a little bit like this, and the distance is 1 over this distance, whatever it is, okay? So W bar is something like this. So all the points here are just identified, all the points here, except the origins. And again, as in the case of real projective plane, as you go infinite, right, as this W has, as the norm of W goes to infinite, then this gadget goes to 0, because if W, let's say, is just x plus iy, this is just x minus iy divided by x squared plus y squared. So this is the norm of W squared. If this gets to infinity, then this goes to 0, right? This goes to 0 as norm of W goes to infinite. Yani bu düzlemde sonsuza giderken noktanız sıfıra gidiyor öbür tarafta. Tersine burada siz sonsuza giderken de burada sıfıra gidiyor. So what happens is that you have these two copies of complex plane and you just identify the points, but so that the points where here that goes to zero, that goes to infinity should go to zero here. Bu da nedir? İşte 2 tane A4 alın, bir topun üzerine sarın. Ona benziyor. Yani bir tanesi so you take this sphere. This is one copy of complex plane, and this zero corresponds to the North Pole, and another copy of the complex plane where the South Pole corresponds to O prime. So this is O, this is O prime, and then you just bend this plane over the two spheres. Okay, each one covers the whole sphere except one point, and that one point comes from the other chart. So it is just this picture. You identify all the points here except zero. Okay, so zero here is not identified with anything, but all the other points are just identified with each other. Yani RP1'da neydi? Real line'ı bu şekilde büküp, değil mi, çember elde ediyorduk. Burada aynı işlemi yaptığımızda bu sefer küreyi elde ediyoruz. So CP1 topologically is just S2, the unit sphere. Tamam mı? Hı. Rastgele bir homeomorfizm. Hı hı. Yani emin değilim. Homeomorfizmler çok garip davranabilir ama hani sonuçta homeomorfizm olduğu için büyük ihtimalle öyle de ama emin değilim. Sumut map olsa muhtemelen dediğin doğru da homeomorfizmden emin değilim. Okay. Now, what about CP2? So this is the point space of equivalence classes like this. At least one Zi is not zero. Okay. Okay. Let me just write like this. And this is the complex projective plane. And this has this time 3 coordinate patches. Right? U0 is just Z0, Z1, Z2, where Z0 is not zero. U1 similarly, Z1 is not zero, and U2 similarly, the same thing, but this time Z2 is not zero. Okay? The topology of CP2 is complicated. I mean, it's not complicated, but it's I don't want to deal with that one. Of course, this here, each of these. So this is just a copy of C2, and what is the map? Z0 Z1, Z2 is identified with this, with the point Z1 over Z0, Z2 divided by Z0. And similarly, here you will divide by Z1, and here you will divide by Z2. So each of these is a copy of C2. And C2 is, of course, this is C times C, but each C is just R2, so this is just R2 times R2, and this is 4-dimensional, okay? Real 4-dimensional object. We call it complex plane, but as a real manifold, actually it is 4-dimensional, okay? And this is not the, S4, S4 is 4-dimensional, but this is not S4. S4'da Quaternion projective line aslında. Yani bu bütün construction'ı Quaternion'lara da taşıyabilirsiniz. Peki, şimdi kitabımıza geri dönüyoruz. Now we will come back to the book after this digression on projective plane. Okay, algebraic curves in the complex projective plane. So what's an algebraic curve? I said last time that, if something is algebraic, then it should be defined via polynomials, okay? So we start with a polynomial. Let fxy. I will take real polynomial. Aslında kompleks alayım ya. Bunu zaten az çok konuşmuştuk. Let's take complex polynomial. Okay. And let me write this polynomial like this. So fn xy, fn minus 1 xy, f1 xy, and f0 xy. Here, fi xy, the degree I monomial part of f. Yani derecesi, toplam derecesi i olanlar. Bu n olanlar, n-1 olanlar, işte 1 olanlar, 0 olanlar. Örnek vermek gerekirse, geçen sefer de sanırım vermiştim bir örnek ama bir tane daha yapalım. Şöyle diyeyim, mesela işte x üzeri 4 olsun. Eksi 3 x cubed y plus x squared y minus 5xy squared plus 7xy plus x squared minus 6 x plus 7y plus 13. So in this case, f4 xy, the degree 4 part of this is degree 4, this is degree 4 because this is degree 3, this is degree 1. So you just multiply the degree, add the degree, so it's degree 4. So this is x4 minus 3x cubed y, f3xy, degree 3. I have only, so these are degree 4, this is the degree 3 part. Pardon. Siz de görün. Nedir? X squared y minus 5xy squared f2 xy 7xy plus x squared f1 xy minus 6x plus 7y and f0 xy is 13. Okay. Okay. Şimdi bunun bir tane doğruyla kesişimini bulalım. Let's compute the intersection of the algebraic curve fxy with a line say L ve L şöyle tarif edilsin. Y eşittir lambda x. Tamam. Böyle mi yapmıştık geçen seferde? Hı. Şimdi bu şeyi parametrize edeyim. Eksi alfa t olsun. Y beta t. Burada lambda tabii nedir? Lambda y bölü x. Y bölü x yani beta bölü alfa. Tamam mı? Şimdi real picture'ı çizeyim. F iki değişkenli bir polinom. Sıfıra eşitlediniz. Bu uzayda düzlemde belki şöyle bir şey olabilir. Tamam mı? Y eşittir lambda x'de and y equals lambda x, just something like this. So this is our L and this is f equals 0. And I would like to compute this intersection points. How can we do this? Well, you just, solve this equation system. I have this equation and this equation, but this equation is just solved like this, and here t is just a parameter. So we just plug those into this. So alpha t, beta t equals 0. So what I will do, I just need to find t out of this. Okay? Now, what happens? You see, when you plug this in this expression, şurada x yerine alfa t, y yerine beta t yazarsanız, so if you write alpha t here, beta t here, you get t cubed. And t cubed here, you can just throw out t cubed, right? So f3 alpha t beta t is just t cubed f3 alpha beta, right? So in each homogeneous part, t goes out as t to the power I, and I have f alpha beta. And f alpha beta is just a number, okay? Because alpha beta is fixed, okay? So lambda is fixed, therefore beta and alpha are fixed. Okay, so when you plug this, into this polynomial, so what we will get, 0 equals f alpha t beta t. So this is fn alpha t beta t up to f1 ya da fi alpha t beta t plus f1 alpha t beta t, and finally f0 alpha t beta t. So we get what? 0 is equal to, here t goes out as t to the power n, fn alpha beta. So this polynomial evaluated at the point alpha beta, and then t to the power n minus 1, fn minus 1 alpha beta, up to f1, so t times f1 alpha beta plus f0 alfa beta. T üzeri 0 dışarı çıkıyor. T üzeri 0 zaten 1. Tamam mı? Peki, şimdi ne oldu? Now, our equation this was a polynomial in 2 variables. But now I obtained an equation. It's a polynomial, but it's in 1 variable. And that variable is just t. So we just need to solve this equation, right? These are just complex numbers. Here, fi alpha beta is just a fixed complex number. So this is a polynomial equation in t. And we know from complex calculus that any complex polynomial of degree n has n solutions, exactly n solutions. This is a polynomial equation in T. Now, we have 2 cases. What is the degree of this polynomial? What is the degree of this polynomial? You see, this is a little bit misleading. It seems like, this is a degree n polynomial, but maybe this thing is 0. Then it's not degree n, it is degree n minus 1. So we have to be careful. If fn alpha beta is not 0, then it is an nth degree polynomial kamera orada kalmış. Then it's an nth degree polynomial and it has exactly n solutions. Of course, you may have multiple solutions, then you count with multiplicity. Değil mi? Bir kök birden fazla çıkabilir. So what we see is then, if we have a degree n plane algebraic curve, then a line intersects it with at endpoints. But with this assumption, so if the line is, chosen so that, if the line is chosen so that, this coefficient is not 0, then you have exactly n solutions. Of course, some of them could be, double intersection points. Maybe, this curve is not like this. It could be, tangent to this in this case. So this will be a double point, okay, not a single point because it is tangent. But the thing is that algebra here agrees with the geometry, okay? It's a degree n polynomial, and with a line it intersects at n points. But what if this is 0? What if fn alpha beta is 0? Hatta şöyle diyelim. Indeed, let's assume böyle kameraya bakıyorum ikide bir bana bakıyor mu diye. Yorumlara bir şey yazmış. Hocam gizli kamera mı var? Niye öyle bakıyorsunuz diye. Let's assume this. F ne demiştim? Fn alpha beta up to Fm plus 1 alpha beta is 0, and the mth one is not 0. Yani m'yincisi 0 olmasın. Öncekiler 0 olsun. Then, of course, then this equation is actually, alpha t beta t is actually this. T to the power m fm alpha beta, and goes like this, f0 alpha beta. So it's a degree m polynomial this time, right? This is a degree m polynomial, and it has exactly m solutions. Ama bu kötü bir şey, değil mi? Niye? Çünkü işte line'ın durumuna göre intersection number değişiyor, değil mi? Yani bu slope'u değiştirirseniz, so this tells us what? When if you change the slope of the line, the number of solutions or the number of intersections of the line with the curve changes, but that's not good, right? Yani o zaman cebirlen geometri tam da match etmiyor. Degree n ise equation, her line onu, değil mi, n noktada kesmeli. So here in this case it seems that algebra and geometry doesn't match, but actually it is not, right? Why is that? We had n solutions here. N solutions here. In this case, we have m solutions, and m is smaller than n. So what happened to the other solutions? What happened to the n minus n minus m intersection points? To the other intersection points. Değil mi? Bunu soruyoruz. Yani o geriye kalan n eksi m tane nokta nereye gitti? Nereye gitti? Biliyor musunuz? Sonsuza gitti. Değil mi? İşte o yüzden projective geometriye ihtiyacımız var. Affine düzlemden kayboldu onlar. Ama sonsuzda duruyorlar. Okay. So the answer is, okay, they just went to the infinite. Okay. Görelim. Şimdi bizim line'ımız değil mi? Line is just any line, any two lines are the same, right? I mean, real or complex. So this is just a line. Therefore, this is actually a copy of CP1. Actually, it's a two-sphere complex line, but actually it's a two-sphere. And what was this? This was just C, copy of C, and then you identify, let's say, T with 1 over T. So T, let's say, is this here. So this is the affine piece, let's say. And this contains the infinite point, the infinity. So it corresponds T equals 0. Right? When T equals 0, here you go to infinity. So the ends of this just meets at the origin of the other copy. So to find the intersection points at infinity, I have to replace T by 1 over T and let T equals to be 0. Değil mi? Çünkü T'yi işte sıfıra gönderirseniz sonsuz olacak. O zaman ne yapacağım? Bu denklemde şey yapalım. So in the equation replace T by 1 over T. T yerine 1 bölü T yazarsanız ne olacak? Şimdi 1 bölü T'ye de aslında S diyelim. Hani kafa karıştırmasın. Şöyle diyelim. Yani F alfa T ne olacak? Alfa over S, beta over S. Bu da nedir? 1 over S to the power n, alfa beta. Nereye kadar? S üzeri m, Fm alfa beta artı nereye kadar? F0 alfa beta. Şimdi zaten şunları biliyoruz. This was 0. So everything here is 0 except till to this point. So I have this equation. S is just a complex number, non-zero complex number. Let's just multiply everything by S to the power m. So what we get is just Fm alpha beta, and then S times Fm minus 1 alpha beta, and then I multiply with S to the power m, so we get what? S to the power m F0 alpha beta equals 0. Okay. Bir dakika. Aa, şunu pardon şöyle yazmam lazım. Aa, aa, bir dakika. Şimdi burada paydada şöyle diyeyim. Şöyle diyeyim. Pardon. Şunları şimdi sıfır olduğunu şey yapmayayım ilk önce. Şöyle düşünelim onu. Tamam, özür dilerim. Şöyle. Aa, bu haliyle denklem s üzeri n ile çarparsak, so if you multiply with s to the power n, I get fn alpha beta plus s times f n minus 1 alpha beta r plus m plus 1 okay. Ben şu hatayı yaptım da s ne olacak? Her seferinde bu bir azalıyor. Bu bir artacak. F m plus 1 alfa beta. O zaman şimdi toplamı n olacak. Toplamı n olacağına göre n minus m plus minus 1. Değil mi? S to the power n minus m minus 1 plus s to the power n minus m fm alpha beta and s to the power n f0 alpha beta. But I know what? These coefficients are 0. These are 0. And this one is 0. So what happens? All these terms are gone. All these terms are gone. So we obtain an equation of degree n in S, and S equals 0. S equals 0 is a solution of this, and S equals 0. So actually, let me just write it this way. Şurayı sileyim. Okay, so our equation became this: S n minus m fm alpha beta. We know that this is not 0 by assumption, up to Sn f0 alpha beta equals 0. And here actually I can just take into this parentheses. So I have fm alpha beta, and then S ne olacak? M f0 alpha beta equals 0. Now here S equals 0 is a solution of this. S equals 0, of course, which corresponds corresponds to the point t, which is 1 over s, 1 over 0, which is infinite, and it has multiplicity n minus m. Dolayısıyla işte o eksik olan n eksi m tane çözüm sonsuza gitti. Bu denklemin, değil mi, s eşittir 0 bir çözümü, s eşittir 0'da bizim sonsuzdaki noktamıza denk geliyor. Dolayısıyla so our line and the curve, okay, our line and the curve intersects at infinity, and so whatever infinity is somewhere here, and it is tangent of degree n minus m. Yani şuradaki yerel denklem şöyle. Y eşittir x üzeri n eksi m gibi. Tamam mı? Y eşittir x üzeri n eksi m, değil mi? Bu şuradaki resme bakarsanız burada şöyle gözüküyor bu. N eksi m degree bir tangensi var. Tamam mı? Y eşittir x kare olsaydı parabol gibi teğet olacaktı. X küp olsa işte x küp gibi vesaire. Tamam mı? So that's why actually we work with projective geometry. So we have seen that, we have proved that any complex algebraic plane curve of degree n intersects a line in exactly n points in CP2, of course. In CP2, okay? Affine şeyde öyle değil. Yani sonsuzu hesaba katmazsanız öyle değil. Yani bazı noktalar yok oluyor. Düzlemden yok oluyor ama aslında onlar sonsuza gidiyor. Bu sonuç aslında Bézout theorem diye bilinen daha genel bir sonucun özel hali. Bézout teoremde şey söylüyor. Derecesi n ve m olan iki tane, bunu göreceğiz, ispat edeceğiz. If f equals 0 and g equals 0 are two plane curves of degree m and n respectively, then they intersect at m times n points in CP2. Bu durumda işte bir tanesini biz m'yi ne aldık? Line olduğu için bu 1. O zaman 1 çarpı ne ediyor? Tamam mı? Yani kuadratik bir körble kestirirseniz 2 ile çarpacaktınız derecesinin vesaire. Peki e, ara veririm. Aradan sonra devam edebiliriz. Evet. Benim notlardan yani aslında fena gitmedik. Neyse. Okey.